All right, welcome to MCR 4, day 5. We are still in Protected Matters Unit 1, and today we're going over basic unit conversions, common conversions, and so forth. So you've got your American units of length, weight, and volume. So we're going to give you all of these common ones, but ones to kind of look at when we're looking at these is when they say 12 inches is 1 foot, that's the equivalent of 1 unit. If you go and measure 1 foot, you could say it's 1 foot or 12 inches, but it's still 1. I could also flip it to be 1 foot is the equivalent of 12 inches, which is 1 unit measurement as well. So going down here, we have our weight, we have tons, pounds, and ounces. So I could say 1 pound is 16 ounces, which is the same as 16 ounces is 1 pound. Because when you physically go to weigh that object, it's still that same weight, no matter how you describe it. And then for volume, we've got gallons, quarts, cups, pints, tablespoons. All of those are in that box as well. So again, when I read it, it says 1 quart is 2 pints, or I could flip it, 2 pints is 1 quart. So what we're going to try to do is write the fraction the correct way so that the units cancel and you get what you're looking for when you cut it out. So with that being said, if the units you need canceled are in the numerator, you cancel them by putting them in the denominator. So if I want to get 8 feet to inches, I need to cancel the feet part and put the inches on top. So when you have that, it extends. Anything on top and bottom can cancel with multiplication and division. So the feet will cancel, and now we'll put in 1 foot is indeed 12 inches. And then you come up with, to figure this out, 8 times 12 is your 96 inches. So then over here, if I want to do the second one, 2 pounds to ounces. Grab a different color. I do my 2 pounds. And I need pounds on the bottom. And then I want ounces on top. So for the 2 pounds to ounces, that'll cancel my pounds. And I like to do the units first, and then I'll look at what the conversion is. Now I need to look for an ounce to pound. 16 ounces are in 1 pound right here. So that's going to give me 2 times 16, is 32 ounces for that one. All right, take a look at question 3. If I want 36 quarts to pints, let's see what it says. 1 quart is 2 pints. Quarts will cancel. So that leaves me with 72 pints. And then for question 4, I want 2 miles to yards. Now let's look and see if we have that conversion. We have miles to feet, and we have feet to yards. So that's what we're going to have to do for number 4. I don't see a direct miles to yard up there. And occasionally you do have to do a few. So we're going to go miles to feet, feet to yard, and get it that way. So I have my 2 miles, and I want miles to feet, and then feet to yards. And what that'll end up doing is canceling my miles, canceling my feet, and leaving me with the yards. So let's see what that turns into. So there are, let's see, 5,280 feet in a mile and 3 feet in 1 yard. So what I'm going to do is 2 times 5,280 and then divide that by 3. So everything across the top gets multiplied. Everything across the bottom gets divided, and that gives me 3,520 yards for question 4. Then the next one we're going to talk about is the metric system. So this was our American units. Now we're going to go on to the metrics. Metrics work on powers of 10. So positive exponents are multiplication. So 10 to the third means 10 times 10 times 10, or 1,000. So you're making your number larger. And what it does is if I have that 2.5 over there times 10 to the third, it moves my decimal 1, 2, 3 larger. Negative exponents are the same as division. So if you have x to the negative 1, that's 1 over x. So if you had something that's 10 to the negative 3, that's 1 over 10 times 1 over 10 times 1 over 10, or 1 over 1,000. That's like dividing by 1,000. So if I take my example, which is 2.5 times 10 to the negative 3, that's moving that decimal 1, 2, 3 to make it smaller. And I've got that detailed below. So again, it works on powers of 10 and moving the decimal. So that positive exponent is like multiplying, the number becomes bigger. The negative is division, so the number becomes smaller. And this number, the exponent, also tells you how much to move. So to the 0 means don't move, because anything to the 0 is 1. So just a quick message there. So pause the video, try questions 5 through 8, moving those decimals. So once you've tried them, this is multiplying. So this is 0.575 times 10 twice. So 1, 2, it's going to make it bigger. For question 6, that's 0.00765 times 1 over 10 times 1 over 10. So it's actually going to make it even smaller. So we've got to watch our zeros because this is going to move it another 1, 2. So I'm going to have 4 zeros. 1, 2 more, 7, 6, 5. And if you're ever not sure, take the number, divide it by 10, divide it by 10 to see what you'll get. No worries there. For this one, it means divide it once or move it once. So move 1 decimal smaller. So move it 1 place smaller. And then this one is move 8 places bigger, larger, because it's like multiplying by 10 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. We just add on any zeros we need, and it's approximately 100 million there. Okay, so that's a metric unit. Metric units work on powers of 10, but the actual metric system now works on base 10, the same for all your measurements. So the American system with units is not based on a power of 10. 2,000 pounds is a ton, 16 tablespoons is a cup, etc. The benefit to the metric system is it's based around this idea of a unit. So all length is in meters, all weights are in grams, and all volumes are in liters. And then you get these prefixes on them that mean the same thing for all of them. So you would have a kilometer, a kilogram, and a kiloliter, a hectometer, a hectogram, a hectoliter, a decameter, gram, liter, etc. And then it goes this way as well. So those mean the same thing for all of them. Sorry about that. That one a little haywire. So as I'm talking about this chart, your regular unit of 1 is the same as 10 to the 0 because you don't move the decimal. If you want to go to a deca is 10 of your base units. So it's 10 to the 1. A hecto is 100 of your base units, or 10 to the 2. And a kilo is 1,000 of your base units, or 10 to the 3rd. If you go the other way, a deci is 1/10, 10 to the negative 1. A centi is 100, and a milli is 1,000, or 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. So the great part about it is if you want to go from any one unit to another, say a deca to a milli, you would move the decimal 1, 2, 3, 4 units in the direction you just moved it. So if I had 5 decameters, which is DA, it's a DOM, and I wanted to convert it to millimeters, I'm sorry, then I move it 1, 2, 3, 4, 1, 2, 3, 4. So it's 50,000 millimeters, and it moves in the direction you're moving it. So whichever way you move it, that's where you move your decimal. So that's kind of the cool part. So if we try a few, and feel free to pause if you feel like you have it and try these on your own. If you want to go from dals, decaliters, to liters, you're moving your 2 1 unit. So you're moving your decimal 1 unit in the direction it's going, so you get 20 liters. If you're doing kilometers to meters, that's 1, 2, 3 in that direction. So this is 7 kilometers, 1, 2, 3, making it 7,000 meters. If I want to go centigrams to gram, I'm moving 1, 2. So my 5.8, the decimal is moving 1, 2, making it 0.058 grams. Then if I want to go decimeters to DOMs, 1, 2. So if I have 362, 1, 2, 3.62. And to avoid confusion, the deca is DA, the regular deci is D. So you'll have DOMs, DALs, and DAGs for the deca. Okay, try these. And then while I'm here, I wanted to point something out. You'll have this in your 154, but if you don't, a quick mnemonic is King Henry doesn't usually drink chocolate milk. And I just use it really quickly to move back and forth on these. So if I want a dal, which is right here, to a regular unit, I've moved 1. So I moved it 1 to be 54 liters. Kilometer to meters would be 1, 2, 3. U stands for the unit. So I would move that 6, 1, 2, 3, 1, 2, 3 to get meters. And then finally, I'm going to write it out again. If I want to go centigrams to grams, the U again is the unit. So it's all of those. 1, 2, 1, 2. So it's 0.87 grams. All right, then what we can do is convert our American to metric. Now we would have to have some type of conversion chart or know these conversions because they don't work on a nice power of 10, but we have them. Over here, it tells you what a kilometer is to a mile, what a kilogram is to a pound, etc. And it would be perfectly reasonable to go back and forth here. So if I wanted to do 13 miles to kilometers, in order to have it cancel, miles needs to be on the bottom, kilometers on top. And then I can put in my conversion 1 to 0.62. So that's 13 divided by 0.62 is 20.97 kilometers. All right, try question 17. So for this one, I want 65 kilograms to pounds. So kilograms on the bottom, pounds on top. So you're going to multiply and get 143 pounds. All right, so that's going to part one of today. Part two is a little bit with geometry, putting some shapes in and putting some conversions there. So on the last page of this, I have some formulas that you should generally look over, remember. Big ones are rectangle, perimeter, and area. Perimeter is your fencing. So it's the outside. Area is the carpet or the soil, that's the area. So perimeter is 2 of the lengths, 2 of the widths. Area is length times width. That's really the one we're going to use the most. But I have a couple of the common shapes up there just in case. So to start, if we review our problem solving techniques. So step 1 was understanding the problem. Draw a figure here. That might be really helpful, and label what you have. Then translate it, try to put stuff on the figure. Solve it, and then always check your work. If the total fencing is 40 feet and you have one side is 100 feet, something probably went wrong. How are you going to do a 40-foot fence on a 100-foot piece of property, etc. So in this one, we've got the length is 1 inch more than 3 times the width, and we want the dimension. So we need to remember perimeter is 2 times length plus 2 times width. We have that. What we're looking for are the dimensions, meaning when we're done, we want the length and we want the width. Okay, so there's understanding the problem. We want the length, we want the width. This is where we're headed. Then our second part, translate to math. The length is 1 more than 3 times the width. So I direct translated that is 1 more than 3 times the width. So on this, I had my width, and this was my length, but it's 1 plus 3W. Why am I doing it that way? Because I need to be able to put this in one equation with only one variable. So the perimeter is double the length, double the width. It's 26. The length is 1 plus 3 width, and the width just is what it is. So now we can solve for W. So 26 equals 2 plus 6W plus the 2W. 26 equals 2 plus 8W. Subtract the 2. 24 equals 8W. So close, we're almost there. W equals 3. Awesome. And then the length was 1 plus 3W, which makes it 10. Okay, then we're going to go back and check. If perimeter is 2 length plus 2 width, then it's 2 length plus 2 width. 20 plus 6 is 26. We're good to go. And then those just stay in inches because they were originally in inches. Now, when you look at area or volume, with area and volume, you're now multiplying units together. So with area, say it's 3 inches, so you're doing inches, times that 10 inches, you're doing another set of inches. Your units are actually going to be inches squared. So when you do area, you'll always have units squared. When you do volume, it's length times width times height. Think of you're now filling a flower bed with soil. You've got the area, but then you're adding the height component. So you'll have units cubed. And make sure these formulas in red, you do kind of note, I should be able to have area of a rectangle and volume of a rectangular solid and perimeter kind of in my toolbox of math equations. So when we go to look at area problems, it says find the area of a rectangle that's 3 feet by 12 feet. So what we would do is we would multiply them together and then have feet squared. But then it now says find the area of a rectangle that's 10 yards by 8 yards. Okay, that's 80 yards squared. But now it says convert to square feet. Okay, so down here I have this block here, one level of a Rubik's Cube. Well, there's 3 feet in 1 yard. But if we have yards squared and feet squared, there's actually more. So in 1 yard right here, you have 3 feet. But if you then go the other way, you have another 3 feet. So in reality, 9 feet squared go into 1 yard squared. You don't have to remember that though. Here's what we're going to do. If we have 80 yards squared, that's 80 yards. That's exactly what I just did. We're going to convert it to yards to feet twice. And that's going to give us the 9. That way this cancels, and I'm left with my feet squared that I wanted. So there's 3 feet in a yard, do it twice. That's where the 9 comes from. So it's 80 times 3 times 3. Which is 720 feet squared. And then if we look at our last page of notes for today, if we go to volume, if we're looking at 1 cubic yard, a yard by a yard by a yard. We've already got 9 on each piece, but then we also have 9 down and we have 9 on this other part. So to do the yard cubed, you're actually doing the conversion 3 times to get to a foot. So there are 27 cubic feet in 1 cubic yard. And it's because that number is telling you how many times you have to do the conversion. It's a 3 by 3 by 3 or 27. So up here, if we want to find the volume of a 3 by 4 by 2, all feet, that's 12 times 2 is 24 feet cubed. Then we want to find the volume of a 5 yard by 2 yard by 3 yard. 5 times 2 times 3 is 30 yards cubed. but now we want to convert it to feet. So 30 yards cubed. Since I did the conversion up here, I'm going to jump to it. There's 27 cubic feet in 1 cubic yard. So it's going to be 30 times 27 or 810 feet cubed. And there we go. That is the end of day 5. You can now work on your day 5 assignment.